Hello everyone, welcome to this R tutorial. The title of this tutorial is Visualization in R using ggplot2. My name is Joey. So in this one, we will continue talking about how to use ggplot2 for data visualizations. So in this one, we will specifically talk about different types of geometries. So this is what we're going to do in this tutorial. First, we will have a quick record from what we have done in the last tutorial. Then we will talk about two different types of geometries. One is the point plot or the scatter plots. Another one is the line plots. At last, I will give the references so that the attendees can take a deeper look or further look after this course. So in the last tutorial, we have a quick introduction of different functions or grammars used in ggplot2, and one of the most important feature with grammar is how to visualize using different geometries by using the geom slash function. So this X means different types of geometries we can do in ggplot2. So one example is the scatter plots or the point plots. So where we need to assign the x-axis, the variables for x-axis and y-axis, and then we can do a bunch of adjustment by using the theme or the other cores or scale functions. So like I said, the first family or first category of geometries are the point or scatter plots. So here I'll just mainly introduce two most widely used point plots. One is the scatter plot, as we have shown before. So that is realized by the geom slash point function. And the second most used one is the hexagon plots. That is realized by the geometry hex function. So these point plots can show the relationship between two continuous variables placed in x-axis and y-axis. So here the first two examples are still given by the empty cars dataset. So as you can see, there are four plots. The top two are the scatter plots, and the bottom two actually are the hexagon plots. So you may wonder why we need to use the hexagon instead of scatter plots. So that is not obvious if we only look at the small dataset like the empty cars dataset, because it only has a few samples or instances. But what if the dataset is pretty large? It has lots of samples as what is contained in the Delmon's plots. So this one actually it can show the relationship between the Delmon, the car rate, and the price. However, it has much more samples than the empty cars, which makes it pretty hard or challenge to observe, because for example in this area most of the points are stacked with each other, and second, that will make the plot pretty large. For example, this plot, the size of this plot is 1.5 megabyte, which is pretty hard to load and for further manipulations. However, if you use the hexagon plot like this one, we can see that this can clearly show the statistics in this case, that is the count of the samples or or the points in this area, and the size of this one is only 12 kilobyte, which makes it much easier for further adjustments. Then the second category of plots are the line plots. So here we're going to use the RStudio to give further examples. So the first subgroup of the line plots are the reference lines, right? For example, the horizontal lines, the vertical lines, and the linear regression lines. So here again we need to specify the x-axis and y-axis, and in this case let's just add the points as the second layer for better demonstration, and we can use this y-intercept to specify where we want to put these horizontal line. So in this case, we want to add a horizontal line at 20 in the y-axis. So that's what we will get. So what if we want to add more than just one horizontal line? We can do that by assigning it multiple values. So that will give us more than just one horizontal line. So the same strategy will be applied to the vertical lines. For example, if we just want to add one vertical line at the 200 y-axis values, then we can just put one value, assign one value to this x intercept. What if we want to add more than one? We just assign more than one value to this x intercept. So what if we want to show the relationship between these two variables? Let's just fit a linear regression function. So here the intercept is 37, and then we have this slope. So let's just assign those two values to the intercept and slope of this f9. Let's see what we will have. So here we can have a linear regression curve on top of the scatter plot. So the other nine, the second subgroup of the lines are the curve function, the step curve, and moving average lines. So those are the three most widely used curves. So again, we need to specify the x variable and the y variable, and we use geometry line, geom step, and geom smooth for those three types of line functions. Let's see what we can get. So here we use the economics database, and let's see what does this database looks like. It has the date, it has several other parameters. So let's just use the date variable and employee variable. In this case, we can get the line, the curves, the step function, which is slightly different from the lines, because these are the step functions. And we can also get the moving average, and we can always change the number of this span to change the number of samples for that moving average. So if you use smaller values, then this moving average will converge with the original line. If we use the large values, that will make this moving average span over multiple samples. Then we will I'll provide three main reference for the different geometries, including this ggplot2 official help site, and an elegant and the reference for the elegant graphics for data analysis, and this ggplot2 quick reference, which is a pretty nice table summarizing how to use different geometries in ggplot2. Yeah, thanks. We will see in the next tutorial.